Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our get file stats function, and we're going to take a look at one way to solve the problem about trying to find some information about your file. And so if you look at the instructions for the data type storage.c, one of the things that you are asked to do is to provide some statistics for a data file based on the type of data that is in the file. And so I've provided you with some sample output and some things that you might want to report back to the user, particularly the file name that you have analyzed, the number of items in the file, the minimum value in the file, the maximum value in the file, and the average or mean value in the file. Additionally, we would also like to provide a count of how many instances of each piece of data there are in the file. So for this example, what we're going to do is we're going to focus on integers. The approach that I'm going to take for the integer data type can be then applied to the double and to the char. In later videos, I'm going to take a more advanced approach to doing this problem. But for this example, I'm going to focus on a fairly straightforward, albeit a little bit of a brute force approach, but essentially would be the approach that you would take if you were prototyping or trying to do this for the first time. Long story short, you can worry about refining the process later. Additionally, for this example, you're going to need an input file that is going to have a little bit of data in there. Now, you can either make an input file utilizing the add file data function that we created in earlier videos, or you can simply find a sample input file such as the one provided for earlier projects. In this case, I'm going to use my sample_01.txt from my sorting examples. Now, the idea here is that I have a range of data, in this case, integers, and you'll see that I vary from values from 60 up to 99. And you can see there's my 60, and then mixed in here will be values up to 99. The idea is that I want to be able to provide some information about the file. So we can quickly see that the minimum value would be 60, the maximum value would be 99, and so on. But additionally, what I want to do is I want to count up the number of times I see 60, number of times I see 61, and so on. And so the idea here is then that we want to produce an output file that keeps track of the frequency of each type of data. And so if you'll notice here, I have a format associated with that as well. And that is going to be the value and the count. Now, for this particular example, I am not going to worry about the order in which you are collecting the values. In other words, I would expect the frequency.csv to reflect the order in which you first saw a piece of data. So if you go back to our sample_01.txt, you'll notice that the first value is 93. So the first value in our frequencies.csv would be 93, and then the second column, or the value after the comma, would have the number of times that we saw 93. The next row should have 97 and the number of times we saw 97. The third row should have 65, the number of times we see 65. The fourth row in the frequency.csv should actually have 85 in it because we've already seen 97. If anything, that's going to increase the count or the number of times that we've seen 97, and so on. So basically, we should be able to then essentially inventory an input file to be able to determine how many of each item we see. This can then be extended not only to integers, but doubles and chars. And then much later on, we'll take a look at how you would apply this then to strings. So without further ado, let's go ahead and get started. What we're going to do is we're going to create a couple of helper functions, much like what we did with our add file data and our add file int. Now, as long as we use the get file stats that was requested by our client, it does not matter if you add some additional helper functions with a different function signature. And so to give you an example here, what we're going to do is we're going to follow roughly the pattern that we did for the add file data and the add file int, in that we have an int get file stats, and then what I'm going to do is simply append then the data type that we expect to be processing. In this case, it's going to be an int. Now, the rest of the function signature is going to utilize the input file name and the output file name. At this point, we no longer need to specify the data type, because the only time we will be calling this function is if we already know that we have integers in the file. Long story short, we simply want to then have a char constant input file name, just like our parent function or a triage function, and a char constant output file name. And at this point, what we can do is we can actually go ahead and predict where we're going with this and create two other helper functions, a double and a char. Now in this video, I'm only going to focus on the get file stats int, and I'm going to leave it to you to complete the get file stats double and the get file stats char. In much later videos, we'll actually cover a way to do this in a slightly different fashion. Instead, what we want to do is we want to focus on this first example. So I'm going to go ahead and copy all three of my newly created function prototypes down to the bottom of my file, and I'm actually going to put it below my get file stats. As we've done in earlier examples, we simply expand the prototype into the function implementation, and we go ahead and utilize somewhat of a template for our comments. So we want to have a name field and a description field, as well as creating a default return value. Sorry, that went into the wrong spot there. Let's move that down a little bit further. And then once again, in front of the get file stats char. Now, this default template, if you would, for the return value is going to be the same. It's going to be an int results. And at this point, then the only thing we need to do is just simply change what the printf statement provides. In this case, we're going to change this to get file stats int, get file stats double, and then lastly, get file stats char. As I mentioned just a few minutes ago, we're going to focus more on the get file stats int in just a second. The first thing that we want to do is triage using our get file stats, the data type argument. This is going to be done exactly like the add file data and the remove file data that we had earlier. As a matter of fact, if you've already watched those videos, you can simply copy and paste some of the code and make some minor modifications. If you're following along for the first time, essentially what we're going to do is we're going to use our string compare I function to simply compare the value in the data type variable with the data types we intend on handling. For instance, if we intend to handle an int, we simply see if the data type variable holds the string int in it. Likewise, we can continue now with our other scenarios, our double, our char, and then lastly, an else that would simply provide a message back to the user that says error unhandled data type. And at this point, what you could do is you could simply tell the user what you were unable to handle by providing a %s followed by a new line and then simply your data type variable. Now, what would we like to have happen when the user provides the int data type? Well, the idea here is that we would call then one of our more specific functions, providing to it or passing to it the input file name and the output file name. So at this point, what we can do is we can simply use results to store the return of our get file stats int. And at this point, the only thing we have to pass is our input file name and our output file name. We can do the same thing now for our double, as well as our char. Now, this might seem a bit excessive, but this has a couple of benefits. One is it keeps our get file stats from doing too much. In other words, we'd have a bunch of cluttered code in this function. And so by creating this hierarchical approach, we do create more smaller functions that we have to manage, but it results in cleaner looking code. It also allows for you to modify or improve the algorithm for a particular data type. This will be increasingly important as we start providing support for more sophisticated data types. Now, we're going to focus in on the get file stats int. And the first thing that we want to do is go back to our instructions one more time and refresh our memory on exactly what our goals are. In other words, what are we actually trying to accomplish here? To begin with, we simply want to print out an output file that has information about whatever the input file was, particularly the file name, the number of items in the file, the minimum value, the maximum value, and so on. So we can already see that we're going to need a few temporary variables, not the least of which is going to be our input file pointer and our output file pointer. So we'll start off there. We'll have a input file pointer, an output file pointer. We're already going to see here that we need a minimum value. So that in this particular case will be an integer. We also see that we're going to need a maximum value and then a mean value. Now, if you've already attempted to calculate some of these earlier, you'll know that part of calculating a mean or an average value will mean that you're going to also want to have a total. So in this particular case, we know that we're going to want to have a total variable, as well as some way to keep count of the total number of items in the file. And in this particular case, we'll just simply utilize a count. Now, I'm going to get back to the frequency.csv in just a minute. I want to focus first on these basic statistics, if you would. So the first thing that we want to do is we want to successfully open our file, particularly our input file. So we want to start off by saying input is equal to fopen, and we want to open our input file name for reading. As always, we want to check to make sure that our input file is not equal to null. If it is, we want to provide some sort of message back to the user that says error, failed to open, and the file name. So in this case, failed to open %s. And we simply provide the input file name. Now, as in earlier examples, we could do a little bit more error checking of the input file name, particularly to make sure that we actually have a long enough string for a valid file. At this point, we're going to assume that was done earlier, although we may come back and revisit that if necessary. The second thing that you want to do is you want to make sure that you can, in fact, open your output file. And so in this case, there is no point in continuing calculating statistics if you can't actually return the results back to the user. So in this particular case, what we want to do is, once again, have another if statement, excuse me, we would want to go ahead and open the output file. So in this case, it would be output equal to f open. And then we would attempt to open our output file name. And we would open this one for writing. And we would want to check to make sure that our output file pointer was also not equal to null. And if for some reason it did wind up being null, we simply want to specify back to the user a message that says error failed to open %s. And in this case, what we want to do is we want to provide to the user the output file name. Now, before we go any further, let's think about which scenarios we would want to close the file. Well, the output file only needs to be closed if, in fact, it was successfully opened. So in this branch of the if statement, we would want to provide a f close for our output. Now, we've not done anything with it yet. That data will, or excuse me, that code will come. But then also, if you look at the way we've nested our if statements, we also at some point want to make sure to close the input file. But note that there is another scenario under which we have successfully opened the input file, but have not successfully opened the output file. So you need to make sure in your other branch to also provide a fclose input. This redundancy just makes sure that you do not leave the input file open any longer than it absolutely needs to be. Now, at this point, we're ready to start reading the data out of the input file. Keep in mind, we want to keep track of the count or the amount of data that we have in the file, the min, the max, and the mean. So what I'd like to do now is I'd like to go over to our sample 01.txt so that we can sort of visualize it in our mind what we're wanting to do. And the first thing that we want to do is simply attempt to read some data out of the file. So in this particular case, then what we want to do is we want to have a while loop that utilizes our fscanf. We want to read out of our input file. And since we know that we are dealing with integers, it's going to be a %d. And we want to store it somewhere so that we can ultimately compare it. And in this particular case, we're just simply going to create a temporary variable called chunk. And we're going to store then the value out of the file at the address of chunk. And we're going to continue this while this is not equal to end of file. Well, this means that we need to have one more temporary variable, and that is our chunk variable. So we're going to start off here with an int chunk. Now, as we are pulling data out of the file, we want to start initializing some of our values, our min, our max particularly. So this gets us into an interesting dilemma. How do we know what a good default value for min and max are if we don't know what the data is in the file? Let me give you an example real quick. So if we initialize our min to 0 and there is no data smaller than our min in the file, then we inadvertently, artificially set the min equal to 0. Likewise with the max, if we set the max to a value that's too high, in this particular case, if we set the max to something like 100, then we would not have a higher value in our file. We've got a couple of ways that we can get around this. First, we could simply read in all of the data into the file and attempt to figure out what the maximum minimum value are by simply pulling out the first value in the array. This is an expensive process because it simply stores all of the data in the file into random memory. The problem with that is it works fine for a small file, but not so well for a larger file. Instead, what we want to do is effectively read the first line in the file and use that as a seed for both our min and our max values. To do that, we simply want to go ahead and do another fscanf. And particularly what we do is we put this one inside of an if statement. So if fscanf, once again, our input file pointer, and we utilize our %d because we know that we're dealing with integers, and our chunk. If this is not equal to end of file, that means that we have successfully pulled out some information from the file that matches our format spec. At this point, then, we can simply set the min equal to the chunk and also the max equal to the chunk. Now, at this point, that means that any value that comes after that will at least be compared to a legitimate value in the file. But then let's think about the repercussions of this. If the file itself has no data in it, then that means that you would have effectively hit your end of file upon the first fscanf call, in which case we have no data to process and no reason then to provide a min and a max. Likewise, if our fscanf does not encounter our end of file, then that means that we can essentially move our while loop inside of this branch of the if statement. And so that the only time that we're going to continue to attempt to read data out of the file is if, in fact, the first attempt did not result in an end of file. So essentially, under the else of our if else means that we have a file with no data. As a matter of fact, you can probably at least print a warning, if not an error, to the user that says your input file has no data. So I tell you what, we'll go ahead and leverage the file name. So has no data. Once again, it's just about providing some useful information back to the user. Now, at this point, you could argue that we could also rearrange where we are closing our input and our output files. You could also make a strong argument that it was probably worth checking to see if our input file even had data in it before we attempt to open the output file. There are several ways that we can go about doing this. I'm just trying to focus on a more straightforward approach for this first attempt. At this point, then, what we can do is we can continue to read chunks out of our file. And what we'll do is we'll simply compare it to the existing min and max. And if a new lower or higher value is found, we simply replace that with the temporary variable. We're not interested then in looking at the location of those chunks necessarily. The last thing that we want to do is after we read out that first chunk of data, we simply want to increment our count. Now, this is a variable that we did need to initialize at the beginning. So we probably ought to take just a second to go ahead and initialize our count as well as our total. We'll see that we can actually initialize the min, mean, and max in an alternate way, or at an alternate location, rather. Inside of our while loop, we're simply going to set up an if statement for our min and our max. And in this case, what we'll do here is if our chunk is less than our min, this simply means that we have found a new low value. And we'll simply say min is equal to chunk. Now, our else branch technically has no code in it, so we're just going to simply put do nothing. At this point, we do the same thing for the max. So if chunk greater than max, that simply means that we have found a new high value. And at that point, we simply say max equal to chunk. Else, do nothing. And then no matter what the date is, in other words, it may not be a new min or a new max, we simply want to say total is equal to total plus whatever the value is in the chunk. And then we also want to go ahead and increment our count. Now, at this point, assuming that you have survived the while loop, in other words, that you have went through the while loop continuing all the way through to the end of file, you should have a minimum value, a maximum value, a total associated with the file, as well as a total number of elements. But you'll note that we have only been summing the total inside the while loop, which inadvertently forgot that first chunk. So likewise, in addition to incrementing the count earlier, we also want to set our total equal to the value of the first chunk. At this point, once we have completed the while loop in our true branch of our if statement, we are ready to start writing some of the output for our file. And once again, we're going to come back now to our instructions so that you can borrow some of this or recreate it in your output file. And notice now the stats.txt is user defined, meaning that it comes from our output file name. The only thing we want to do here is simply use a printf, perhaps to create a nice border, or rather an fprintf to create a nice border utilizing our output file pointer. And so I'm just going to set up a border here of equal signs. Doesn't have to be anything fancy. Followed, of course, by a new line. We'll probably want one of those at the end of our table as well. For the first output for the file, we simply want to specify the file name. And at this point, then put it somewhere a few tabs over, followed by a %s. We can clearly clean this up later. And the input file name. Continuing with this, we want to do an fprintf of our output. And we can provide then the min value. And once again, we can play around with this. We can clean this up. I'm going to put down a %d. And then in this case, I'm just going to put in the min value. We can do the same now with the max value. And the mean value, which is going to take a little bit more effort. We also want to decide what exactly is the mean going to be. Well, we have it initially calculated or declared rather as an integer. You could also argue that the mean value, even for a file full of integers, should be a double. And in this particular case, essentially what I'm going to do is I'm going to allow for integer division and simply accept the results of the integer division. So what we want to do now is outside of our fprintf block, we simply say the mean is equal to the total divided by the count. Once again, we can consider and should consider possibly converting that to a double, much like the example here. We'll play around with this some more. At this point, we should have a functioning output. The only thing to note is, what do we provide when in fact the file has no data in it? My suggestion to you would simply be to provide an abbreviated output. And what I mean by that is simply provide it with the file name, and for the additional fields, what you can do is provide something like NA, so not available. So let me give you an example on one of these, and then you can decide if you wish to include it or not. So in this case, what you would do is simply specify NA followed by a new line. And you can do the same thing then with your min, your max, and your mean. Now we have one other piece of data that we have not yet included, which is the count. And that one's also very easy to add in both places. So I'm going to start up at the block where we actually have a count to include. And in this case, it's going to be the output count and then tab over. And it also is a %d followed by a new line. And we simply then provide the count. Now, if you'll notice the way we've initialized the count, which is outside of our block here, we actually have a value for count. So this code doesn't really change even if your input file has no data. It's just simply going to say that the count is 0. Once again, it might be a good description back to the user. At this point, I would suggest that you stop and go ahead and build your function, build your executable, and let's see if we've actually accomplished something. All right, so we have a build failed. Let's go see if we can figure out where our error is. It looks like, accidentally was playing around with something and left that in. My apologies. Let's go ahead and build that one more time. All right. So we should have it working now. So let's see if in fact our switches correctly triage not only our main, but also in our get file stats. So I'm going to clear my screen. You'll see that I have my data demo there. I also have my sample _01.txt. So what we want to do is once again use parametric mode. We want to look at our help if we need to. If you notice, it's up at the top right-hand corner of my screen. I'm going to do /stats. I'm going to provide the input file as my sample _01.txt. I know that it is going to be a int, and just for consistency's sake with this example, I'm going to call it stats.txt. And at least based on the feedback in the console, it looks like my get file stats called my get file stats int. That looks promising. If I type in dir, you'll notice that I also have a stats.txt. That's also looking promising. And if I drag my stats.txt into NetBeans, you'll see that aside from maybe a little tweaking on my spaces, I'm pretty close to what I wanted to see in my output file. To be honest with you, at this point, this is close enough. I wouldn't necessarily suggest spending any more time on it. It looks good. I think your customer will be happy. At this point, what I'd like to do is I'd like to now focus on our frequency.csv. And so what we'll do now is we'll move our stats.txt over here, and we'll pull up our sample01.txt. Remember that the idea being is that we will simply count the number of instances in our file. To accomplish this, we'll need to create some more temporary variables, and also we'll need to add some additional code under the true branch of our nested if statement immediately following our while loop. Actually, some of our code will actually be in our while loop, and then the part that writes the output will be outside of our while loop. Now, this video assumes that you've at least taken a look at the data counter, our word count, int count, etc. Although I will be going through the entire algorithm here. So to begin with, we're going to need to add some other variables here. And particularly, we're going to want to add 2 parallel arrays or vectors. And essentially what we want to do in our frequency.csv is to have the first column be the data and the second column be the count or the frequency at which that data occurs. And so I'm going to go ahead and create 2 vectors here. One is going to be data, and I'm going to go ahead and make it 100 elements long. Now I'm hard coding the 100 here because we're going to deal with dynamic memory allocation in another video. And so 100 should be more than enough room for us to catalog this particular integer file. Adjust this size as necessary. The second vector or array that we're going to create is going to be our data count, and it simply is going to be the same size, and it is also going to be an integer, and it is going to keep track of the number of instances of the data in our file. Also, what we want to do is create some temporary variables, or rather some indexing variables. One is going to be a found flag and a found index that will simply allow for us to loop through our data. And then lastly, we also want to have a variable called found count. And this is going to indicate essentially the unique, or rather the number of unique pieces of data. So we're going to want to initialize some of these, particularly the found and the found count. We also could initialize our data count, but our algorithm is going to allow for us to do that. And essentially, we're going to make sure that we do not go past the end of the usable data in our data count variable. So really, the only thing that we want to go ahead and initialize is going to be our found count. And we will simply set that equal to 0. Now, once we have successfully opened our input file, a little typo there, sorry about that, found count. Let's see if I can get that spelled right. All right, so found count, there we go. Once we have successfully opened our input file, successfully opened our first output file, and we are then prepared to read the data from the file, we have worked already on identifying the min and the max, as well as keeping track of the total and then incrementing the count. What we would like to do now is we would like to check to see if we have already seen the data before. And to do that, I'm simply going to create another while loop inside, and the while loop is going to allow for us to go from the beginning of our data array to whatever the found count is, or the number of elements, unique elements in our array. So we set up a loop that says while found index less than found count. What we want to do then is we simply want to check to see if we have a match to the data. Now, I've went ahead and nested the parentheses here. You'll see why in just a second, because we also want to preserve that 100. In other words, we only want to capture the first 100 unique values. So we'll need to be careful here in case we exceed that. But at this point, what we'd like to do is we'd like to go ahead and initialize our found index. And we'd also like to go ahead and initialize our found flag. Okay, so essentially what we're going to do here is assume that we have not yet found the data. Likewise, we can also stop our while loop not only when our found index is equal to our found count, but we want to continue our while loop while found is equal to false, because in other words, once we found a match, then we want to stop looking for it. And before we leave this line, we'd also like to make sure that we don't accidentally exceed that 100. So we're going to have a third condition here that says while found count is less than 100. And once again, that's a hard-coded value that we would ultimately like to get around. So if all three of these conditions are met, essentially what we're going to do is we're going to compare the value in our data array using the found index. And if that simply matches the chunk that we have pulled out of the file, it means we have a match. You found a match. Well, what we want to do at this point is we want to do several things. First, we want to flip our flag from found equal to 0 to found equal to 1. We also want to increment the count stored in the parallel array data count. So we use the data count found index, and we simply take the value that is currently there and we add 1 to it. Under the else branch, we simply keep looking. And then before we forget, outside of both branches of the if statement, we would like to increment our found index. Now, note, we can do this outside of our if statement if we are uninterested in preserving which index was the found value. So we can technically put our increment for our found index inside the false branch or the else branch of our if statement, because effectively there's no reason to continue or proceed once we have found the matching value. Also note that the reason this trick works is because essentially all three of these conditions must be true. And once we have changed found equal to 1, this condition right here will break our while loop. Now, being careful outside of our while loop, in other words, this inner while loop, if we have ran all the way through it, all of our options in our data vector, or we have exited the while loop early, we simply have one last check to make. And that is if found is still equal to 0. And what this means is we have found, let me rephrase that, we have a new value that has not yet been found. And how do we handle that? Well, the idea is we have this found count variable that keeps track of the number of unique items in our data. So what we want to do then is we want to utilize that and utilize our data array and our found count variable to simply store whatever that chunk was. Likewise, we also want to initialize our data count vector utilizing that same found count variable. And we simply want to initialize it to 1. So in other words, this essentially says we have the first instance of that data. At that point, when the next instance of that data is found, we simply increment the count by adding 1 to it. At this point, the only thing left to do is to increment our found count. In other words, this will now keep track of how many pieces of data we have, or unique pieces of data we have, as well as being a mechanism for adding new data to our array. Now, the only thing that we do have to do now is figure out how do we actually write this to a file. So we've got a couple of options here. Number one, we can simply move our fclose output earlier into our code, meaning that as soon as we write our output, we close our file as opposed to waiting, which is perfectly fine. This would allow for us to reuse our file output pointer. So at this point, what I'm going to do is I'm going to move the fclose for our file output into each of the branches of the outer if else, or rather not the outer, but this particular if else. At this point, this will allow for us to utilize the same file pointer by saying output is equal to fopen. And this time around, we want to go back to the instructions and remember that we are looking for a frequency.csv. And we want to open this for writing. And if you'll notice here, I have a example, or at least the template, if you would, in the instructions. And we want to store the value separated by the count, and we want to separate that by a comma. Now, we also want to go ahead and check to see if our output is not equal to null. And if it is, we simply want to provide a message back to the user that says error, failed to write frequency, or rather failed to open frequency.csv. At this point, what you can do is simply loop through your data and data count arrays and write the output to the frequency.csv file. To do that, we can simply use a for loop. And in this case, we can use the found index variable. We'll start off at 0. We will continue while the found index is less than the found count, and we will increment the found index. Inside, we simply do an fprintf, with the format spec for this particular example being %d followed by %d and a new line. And in the first position goes the data utilizing the found index variable. And in the second position goes the data count, also utilizing the found index variable. At this point, barring any mistakes in our code, or flaws in our logic, we should be pretty close to getting this completed. The only thing that I would suggest considering adding now is to your stats file a count of the unique number of items you have. And so what we can do is we can add one more fprintf, and at this point we don't necessarily have to match what the variable names are. We'll just say unique and %d, and for this particular variable we simply use the found count. Likewise, we can simply do the same thing below by either utilizing the found count or the NA. And at this point, it doesn't really matter which one you do. Hopefully, you can see the benefits of both. So in this case, I'm just going to leave this as NA. All right, let's see if this works. So we'll go ahead and build it. All right, so we've at least got one mistake here. I am not even going to bother to look at the error because I can already guess what it is, my most common one. I forgot once again to include the file pointer. Let's go ahead and build it one more time. All right, that looks promising. No errors, no warnings. We'll come out here to our console. We'll do a dir. You'll see that I have no frequency.csv. At this point, I'm going to run the exact same example I did earlier in the video, running my stats on my sample01.txt. I'm going to specify that I'm looking for integers, and my output file is going to be stats.txt, but I should also get a frequency.csv. No errors, at least no delays. My executable didn't crash, and I have the right output. And you'll see that I have my frequencies.csv. However, it is a 0-byte file. So we appear to have something wrong here. So we've been able to successfully open the file, but what we did here is we forgot to close it. So the executable essentially quit without closing the file. Once again, a common mistake that you're going to make, especially when you're first programming, and the sign or the telltale sign of that is an output file that has 0 bytes in it. And so in this case, we'll rerun it one more time. Once again, it completed successfully, and my frequency.csv is still a 0-byte file. So what we want to do here is I'm going to go ahead and do a clean build here just to make sure that I don't have any issues there. And I'm going to run this one more time. And my frequency.csv is still 0. So let's see if we can figure out where our mistake is. Essentially, it means that I am not writing to my output file. All right. At this point, if you were following along, you were probably trying to tell me through the video that I had accidentally put in my input file pointer as opposed to my output file pointer. Let's go ahead and build this one more time. And let's run it. And then once again, dir. And this time you'll notice that my frequencies.csv actually has data in it as opposed to a 0-byte file. And then if I drag in it and drop it into NetBeans, you'll see that 97 has 4 instances, 65 has 4 instances, 85 has 2, and so on. Okay, all the way through until you see there's a 60 down there. Apparently, as it turns out, 60 is the last unique value that we find. And that kind of makes sense because not only is there only one instance of it, it also happens to become pretty late in our sample.txt. So it's all the way down here at the second to last value. Now, we also updated our stats.txt, and what we want to do is we want to see real quick, we have 37 unique values, and sure enough, we do. Hopefully you can see now that stats.txt is essentially a placeholder. In other words, as you think of more creative things to add, to tell yourself something about the file, this is where you would go about adding them. Which brings us to one last point. We mentioned earlier in the video that we may like to see the mean as a double, or basically some other value than an integer. And I would like to take just a second to show you how you could go about doing that. And essentially what I'm going to do is I'm going to copy and paste the mean, and I'm going to have a second one here that I'm going to specify is going to be a double. And to accomplish that, what I'm going to do is I'm not going to use my mean variable, but instead what I'm going to do is I'm going to use casting on my total and on my count. So I'm going to use extra parentheses here to specify that I am going to take the total and cast it to a double. And then I'm going to take that value and I'm going to, once again, cast it as a double. Let's make sure that we have enough parentheses here. And I'm going to divide that one by my count. And let's see if we've got our parentheses matched up. I believe we do. Let's go ahead and build this. And at this point, we're going to rerun this one more time, and you should see now that we have an extra row in our data, and you'll see that essentially the integer division resulted in 81, but the average value was 81.13. And you can do something like similar to this with both the double and with the char, although for a char, the mean probably doesn't have as much meaning, no pun intended there. Instead, what you probably would want to do with the char is consider having a most occurrences variable. In other words, which character appeared most in your input file. And you can do the same thing for each one of your other data types. So hopefully you found this video useful. We are going to have some more advanced videos coming in the future that are going to focus on dynamic memory allocation, but essentially you have all that you need to complete now your Git file stats. Once again, if you have any questions or comments, don't hesitate to email me, and thank you for watching.